All right, today we're learning how to solve radical equations, totally radical. So we're going to need to follow some steps. The first step is, when we have an example, so here will be our first example, is we need to isolate the radical. So the radical here would be this part of our equation, and we want to get that by itself and positive. So imagine if I replace this whole radical with, say, the variable u. Okay, and this is actually pretty common at high levels of math to do what's called a u substitution, but it kind of simplifies the equation. If I said get u by itself, right, the variable u, I would hope you know to get rid of 12, add 12 over, and then to get rid of this 4 that's held with multiplication, we would divide both sides by 4. So eventually that's what we'll need to do for this problem. But that's our first step. We always want to isolate the radical. Okay. Next, we're going to identify its index, or what root it is. Is it a square root, a third root, etc.? And for this, this would be a square root, which I guess if I'll color code, we'll keep green. That is a second root, right, or square root for n. So n equals 2. And then we're going to raise both sides of the equation to the nth power. Well, let's go ahead and follow these as we go. So the first thing we said was to isolate our radical. Okay, so I need to get this by itself. So we want to get rid of things held with addition or subtraction first. So we're going to want to add 12 over. Okay, so that's going to give me 4 times the square root of 5 minus x equals 12. The radical is still not quite by itself. To get a radical by itself, that 4 is held to it with multiplication. So to get rid of multiplication, we want to divide both sides by 4. So we divide that side by 4 and that side by 4. And these 4's will cancel each other out. And now we have the square root of 5 minus x equals 12 divided by 4 is 3. So that was step 1, isolate the radical. Okay, we did that. Next would be raise both sides of the equation to the nth power. So here, n, our index, what root this is, if this is a square root, we need to raise both sides, and it tells me to put parentheses around each side. So we're going to raise both sides to the second power. Whatever that index is, that's what we're going to raise both sides to. So raising both sides to the second power. Okay, the reason being, these square and square root operations are opposites. It's like multiplying by 4 and dividing by 4. They will cancel each other out. Or positive 12 and negative 12 when adding or subtracting, right, cancel each other out. So that squaring both sides will get rid of our radical. So we're going to end up with 5 minus x. So over here we broke free of our radical kind of prison, and then 3 times itself twice is 9. Okay, so next it's finish solving for the variable. So how do we finish getting x by itself here? We're going to need to get rid of this 5, which is held with addition or subtraction, but since it's a positive 5, we'll need to subtract 5 from both sides. So these cancel. Negative 1x equals 4. Okay, and lastly, we do need to get rid of that negative sign in front of our x. Remember, that's like a hidden negative 1 being multiplied. So we're going to divide each side by negative 1. And we end up with x equals negative 4. Okay, so we have a potential solution. However, these algebraic techniques sometimes create kind of false solutions, which we call extraneous solutions. So we need to check, if I plug in negative 4 back here, does it make the original equation true? So we need to check by plugging in. So remember, the original equation is 4 times the square root of 5 minus x minus 12 equals 0. So we're going to substitute in for x, my 5's look terrible, sorry. For x, we're going to substitute in negative 4, the solution we got, and see, does the left side also equal 0? Okay, well, inside my radical, minus a negative will change to plus a positive. Minus a negative is plus a positive. And 5 plus 4 is 9. Well, the square root of 9 is 3. So this is 4 times 3. And 4 times 3 is 12. And sure enough, 12 minus 12 will equal 0. 0 does equal 0. It checks out. We got a true statement. It made the original equation true, so it is a correct solution. Okay. However, it is possible to come up with incorrect solutions. So for instance, let me give you an example here. What if we had the square root of x equals -3? Okay, so if I was following the steps, I'd isolate the radical. It's already isolated. We'd identify its index. It's a square root. And then raise both sides to that power, to the second power. Well, here that would cancel out our radical. And -3 times itself twice is +9. However, when I check, if I plug in +9 for x on this side of the equation, we get 3. Does 3 equal -3? No, these are not equal. So this becomes what's called an extraneous solution, something that doesn't actually work. So we had one answer to check and it didn't work. That meant this has no solution. There's no solution to this problem. That is the mathematical symbol for no solution. It's like a little 0 with a diagonal slash through it. So you're welcome to use either of those if it's a no solution. All right, so let's try our next example here. This time it looks like we have a cubed root. So I've copied our steps so we can follow them again. And the first thing we need to do is get this radical by itself. So there's two things to get rid of. We have a 4 held with addition or subtraction this time, and a 3 held with multiplication in the front. So first thing we want to do is get rid of things with addition or subtraction. So let's add 4 over. So now we have 3 times the cubed root of x minus 6. Those 4's would cancel, of course, and we get -6. Okay, we still need to get rid of that 3 in the front. So because it's held with multiplication, we're going to divide by 3. So these 3's cancel each other out, and now we've isolated the radical. The cubed root of x minus 6 equals -2. -6 divided by 3. Okay, now we need to identify the index n. So here's my n value. It's 3. Okay, so n equals 3. And we're going to raise each side of the equation to the nth power and put parentheses around each side when we do that. So in this case, to the third power, since this is a cubed root. That's what will cancel out. A cube root is to cube both sides. So we end up with x minus 6, kind of breaks out of its radical jail or prison there, and -2 times -2 times -2 is -8. Right? You can double check that. But now we need to finish solving for x. And all we need to do to solve for x is add this 6 to the other side. And I think we've got a value to go through and check. Don't forget, it's very important to check in this section because this may be one of those false or extraneous solutions. So let's check. 3 times the cubed root of x minus 6. So I'm just going to put parentheses where x was. Will this end up equaling -10? So let's plug in our value, -2. And simplify in the radical first. -2 minus 6 is -8. The cubed root of a -8, what number times itself 3 times is -8, and you can do this in a calculator as well, we'll show you that in class, is -2. -2 times itself 3 times is -8. Again, we'll show you how to do that with a calculator if you're not sure. Now we can multiply. 3 times -2 is -6. And -6 and -4 does make -10. Once again, we got lucky. This does give us a true statement. So all of that work wasn't for nigh. -2 is a solution. For not. That's what I was thinking of. All right, let's try the next example. So this is a very strange one. If they give you more than one radical, what we want to do is try to put one of them on each side. So they've kind of already done that here for us. And this is kind of an extreme example, but just in case you were to see something like this. So what we want to do is kind of isolate them from each other as much as possible. So we put one on each side, which is already set up for us here. So we're going to say it's already isolated in this case. We'll identify its index n. In this case, they're both square roots. And then we're going to raise both sides to that power. So we're going to square both sides. And that is going to get rid of the radical for us. X squared minus 2. And over here equals x plus 4. Now you might see we've got an x squared, x to the first, some constants floating around. We've got a quadratic. And remember, we spent a whole chapter on quadratics. To solve quadratics, I want to set it equal to 0, and I want to keep x squared positive. So let's move everything to the left side. Let's subtract this x over to move it to the left side of the equation. And let's move the 4 over. I want to set it equal to 0. So hopefully if it's factorable, we can x factor it and use 0 product property. Or worst comes to worst, we can use quadratic formula, right? But I'm hoping we can x factor. So let's see, we've got x squared positive, it's set equal to 0. Let's see if we can x factor this. I need two numbers that multiply to -6 that add up to -1. That's -3 and +2. It is factorable. So x minus 3, x plus 2. And remember, with our 0 product property, we can set each one equal to 0. We just did this in the last chapter as well, so of course you should just know that we're going to end up with +3 and -2. That's a 0 up there, sorry. And -2. So my two possible solutions, which does mean, unfortunately, we have to check both of them, because one or both might be extraneous solutions. So we got to check. Let's plug in, let's do +3 first. So we're going to check +3. Maybe I'll notate that up here. It's checking +3 here. So we're going to plug in 3. Everywhere we see x, I've got x squared minus 2. Will that equal the square root of x plus 4? So 3 plus 4. Okay, simplifying in each radical, 3 squared is 9. Guess we're sticking with green here, that's fine. And over here we can go ahead and add, that becomes square root of 7. 9 minus 2 is 7, and I'm not sure what the square root of 7 is, but I'm pretty sure it equals the square root of 7. So I think we're okay, +3, give that a little check mark there. Okay, that definitely works. Let's check -2s. Let's change colors for that. So let's check -2. The square root of -2 squared minus 2 equals the square root of -2 plus 4. So again, those parentheses are just where x was in the original equation. And this is just the value we're checking. It's not part of the equation. And let's see what we get. -2 squared is +4. -2 and 4, that becomes 2. And 4 minus 2 is 2. And yep, square root of 2 does equal the square root of 2. So that checks out as well. So in other words, this actually has 2 solutions. And actually, if you were to graph these two as individual graphs and look for where they intersect, these are the x coordinates where they intersect. So just to show you that extra add-on, let me show you some graphs. Okay, so here we go. If you check these out, if we graphed each of these, x squared of x squared minus 2, that's the left side of the equation. That's this funky looking graph here. And the square root of x plus 4 is in blue. And if we look for where they are equal, check it out, my x coordinate, -2. And the other point of intersection is +3, -2 and +3. Look at that. Pretty amazing what graphs can do for us. Okay, let's do one last example here. So my radical is basically already isolated on this side of the equation, so that's nice. Let's identify its index. Once again, it's a square root. And so we need to square both sides to get rid of that square root. So we end up with x squared. Here the square root and square cancel. We get 2x plus 15, and I think, again, we have a quadratic. So let's subtract 2x to the other side, and let's go ahead and subtract 15 over. So we can set this equal to 0. All right, we'll leave nothing left on the right-hand side, so it equals 0, and x squared is positive, so hopefully we can x factor. The two numbers that multiply to negative 15 and add up to negative 2 are negative 5 and positive 3. So x minus 5 and x plus 3 are our two factors. And if we set each equal to 0, we're going to get positive 5, and x plus 3 equals 0 will give us negative 3. So my two possible solutions to check are positive 5 and negative 3. So again, I do have two to check. So let's start with positive 5. So we're going to check positive 5 here. So on the left, it's just x5 equals the square root of 2 times 5 plus 15. Well, simplifying in the radical, 2 times 5 is 10. Over here is really just 5. We can get rid of the parentheses there. 10 plus 15 is 25, and the square root of 25 does equal 5. All right, I like it. 5 checks out. Let's try the next one here. Let's try negative 3. Does negative 3 work? So negative 3 equals the square root of 2 times negative 3 plus 15. Well, this side is really just negative 3. Multiplying in there, we get negative 6. Negative 6 and 15 give me 9. And the square root of 9 is 3. Does 3 equal negative 3? Uh-oh. No, it does not. So that means 3, we're giving that guy an X, like as in a no, not a check mark. 3 is extraneous. So we would not include it in our answer set. Like if that's in your multiple choice option on a multiple choice question, don't choose it. In fact, if we look at the graph, we'll even see why. Okay, so here are the graphs, right? Here's the left side, just X in red, the line Y equals X, and then here's this square root graph. And the one point of intersection where they're equal is an X value of 5. And if you actually check at the X value of negative 3, you see they are not intersecting there. That was like a false solution or an extraneous solution. Okay, we'll practice more of these in class. Just make sure you're always checking when you're solving for radicals.